Okay, Assalamu alaikum wa rahmatullahi wa barakatuh. Very good morning to all of you, brothers and sisters. Before we can start Kitab. اللهم انت ربي لا اله الا انت خلقتنا نعوذ بك من هديك وعليك مصطفى اعوذ بك من شر ما صنعت علي يقول ذنبي فاغفر لي فانه لا يغفر الذنوب الا انت. Assalamu alaikum. First of all, before we start, the sound is clear. Everyone at his or her end can hear me clearly.
And that's it.
Okay, good. Okay, inshallah, today we will discuss maybe in brief about a topic very relevant to all our research project. It is more about the sampling process and how maybe we understand sampling in relation to the population. Okay, we'll discuss all the terminology, and you see the figure. Most of the time we have a population, a bigger frame, and we want to take sample from this population. There are so many different techniques or methods to do this sampling, and according to each method will be a relevant advantage or disadvantage can be there. So we want to understand actually in overall the definition and the terminology when we talk about what is the population or the sampling frame or the sampling units, and we want to get an overview about the different type of sampling design methods and techniques, and we toward the end we have some practical consideration actually on how to calculate the sample size. In terms of the terminology, we start by the bigger picture. The bigger picture, we have a population. A population means maybe a group of people in a place, on a country, on a state. They have certain, or they share certain parameter or certain characteristic. For us as a researcher, we interested to estimate, to determine, to work on this parameter. Okay. So the bigger picture, all the people in a place that can have this parameter, and this parameter is of interest to us for research purpose, we can say this will be the study population. Okay, and in the ideal scenario, if we approach or we do maybe very excellent sampling that really represent the population, it has to be the findings of our research or results can be applied or can be what we call inferred to this population, can be applicable, can be represent actually. So the population you expect, the eventual results of your research will apply to, they can benefit because you already represent all of them in case you follow an excellent sampling technique that maybe satisfy the representativeness objective. So in any population, there will be a sampling unit. Of course, population as a population is very general term. Of course, when we go to the practicality to do sampling, you will maybe deal with units. For example, if you maybe do sampling in a university, among all the students, this is your population. So the individual student that you have access to will be one of the units that you may be targeting and you may involve in your research. Okay, kindly make sure brothers and sisters to mute your mic. Make sure to mute your mic. Okay, to avoid any noise in the background. Okay. The sampling frame actually is maybe near to final list of all these units that you may have very maybe quick access or direct access to, and the units is available and may be ready made for you. For example, again, if we go back to the example of the university, if you do among maybe university students in Malaysia, okay, for some reason you don't have access actually to all the students or each and every one of the students in Malaysia. So you do some work, you have some research team here and there, but by the end of the day, in every place, you have need to find potential candidate that you will approach. You don't have the ability to approach each and every one, and this actually the essence of the sampling. Sampling, most of the time, we don't have either the time or the resources to sample or to include each and everyone in the population. So by the end of the day, in every research, we do determine some inclusion and exclusion criteria that lead us to need to find a sampling frame that those individuals most likely we have access to and most likely we will approach. Because not all the people that we will approach will be included in our study. Some will not be interested to participate. Some maybe will not respond even. Some will withdraw. There are so many reasons. So from this sampling frame, this later will be the sample, the final sample that we'll include. So here we can take maybe another picture that perhaps can be more clear. So we have a target population which is very general, a study population that may be more closer circle of the participant or the individuals that initially will be eligible. We have sampling frame, the list of individuals that we can access, we can approach to invite them to participate in our study. And later, of course, we have the small circle representing the sample, the list of the final individual selected to be participate. So the sample, a selected subset of the population chosen by sampling with the objective of investigating. We are researching certain parameter. Okay, this parameter can be different from research, of course, to another. The sampling is a process. How we can obtain the sample? So the sample is the final subset of the participant that will be having the parameter of interest for us, and the sampling, the process that we take, we obtain the sample from the target population. Okay. So far, anyone has any problem? You can follow?
Follow right there.
Okay, good. So the study participant, of course, this one will be among the sample. We have certain participant that will be finally we contact and they consent and they agree to participate in our study. And of course, most of the time, brothers and sisters, even if we follow excellent sampling technique, still there is a possibility for a variation among the sample or the participant in terms of maybe their respondent, their assessment, the parameter actually assessed in each and every study participant. And this variation is normally due to the chance, because actually study participant, even if you talk maybe clinical study, if you maybe conduct research among maybe patients with diabetes, and you assess certain parameter, maybe the diabetes control, or even the BMI, or even maybe certain other parameter, it is not necessary that because they are all patients with diabetes, all of them will have the same parameter at the same estimation. Of course, there would be a variation. This variation maybe perhaps can be due to chance or due to some other reason. If due to chance means in terms of whatever you have to design properly for the study, you have done. You have do excellent sampling technique. You have do certain maybe excellent planning and inclusion exclusion criteria, the methodology, each and everything. You have defined your variables very clearly. So the variation after this, if you have done all the excellent job that you have to do, the variation after this still be existed, but will be attributed to the chance. And this actually what we call the sampling error. Sampling error, most of the time we have discrepancies between the sampling value and the population due to out of the sampling. The diagram earlier on the target population, and is there a difference between? Yes. Sometimes actually, sister, the target population and study population can refer in some reference as the same. Sometimes will be the study population can be a smaller or closer maybe circle or site of the target population. Okay. For example, if you do national survey, for example, national survey. So national survey, your target population, of course, all people in Malaysia, for example, okay? But of course, because this one is not possible, so we go and you will go actually and certain national survey do like this. They select states, maybe some states, and some other states will not be selected, okay? And within each state, they do maybe sampling by different technique. So literally, the target population is all people. The study population in practical, those people in the defined state that the national survey has been approached. Okay, this may be one classical example. Hope they clarify for you. What actually the other variation? Not sampling error. Not due to sampling, not due to a chance. What we called non-sampling error. Non-sampling error actually is directly related to the way you conduct the research. Okay, to the way you conduct the research. Sometimes non-response means the you didn't get the planned responses that you want to get for this particular research. Or it happened. Some systematic bias happened due to or during the planning or conducting the research. One of them, for example, because I think all of us has or most of you, I think, have some research depends on using questionnaire survey. Okay, so one of the maybe major systematic error can happen when the questionnaire itself was not designed properly, in the construction, in the was not assessed for internal consistency, the reliability, for the validation with different set of validation. This actually some sort of systematic error, not related to the sampling, but affect actually the quality of the study. And this is just for your knowledge. We will not discuss bias in details. Perhaps we will have another session for this one. So by the end of the day, after maybe in every research, and even if you do random sampling means everyone have the same chance to be included. Still, we have a possibility. It is not a possibility that the sample that we included, the study participant, will not be really representing the population, because perhaps the incomplete or inaccurate sampling frame, the failure to recruit enough of the eligible subjects you want to include, they have been approached, but they didn't consent, or they didn't respond to our research, or they respond initially, especially in clinical study, they included, and then drop out or withdraw on the way. They didn't complete. So we have to ask ourselves one logic question: why do we need a sample? What do you think? Why maybe perhaps anyone do research, maybe include each and everyone who might be eligible to respond to this research, or for some other reason? Why do we include each and every one? And alternatively, we do sampling. Sampling takes some of them. Why?
Maybe the study population it's too large for us.
Okay, good. A study population is too large, of course, and as one of Nabil Husseini, brother Nabil, say already limited resources and manpower. This very correct. Of course, if you go for the study population or even the target population, it's too costly to study all. It is not actually maybe visible in terms of the resources. In terms of logistic, even as I mentioned in the national survey, and we have experienced, one of our colleagues here was involved in a national survey. We have experience in this one, even in a national survey, as I explained, sometimes they even cannot approach all the states, even in the national survey. So you can imagine logistic problem. So when we go back, when we go maybe down to the individual research capacity, it will be really maybe not visible in terms of cost, logistics, and of course the manpower and time. Time, for example, your research project for this semester, of course you have time frame to present, maybe propose a time frame to go for maybe the data collection time frame to present findings. All this have a time limitation. With time limitation, it is not possible to approach each and every one. And sometimes, but of course it is not applicable to your projects. But sometimes you have a study that have some harmful effect or some destructive procedure. Of course, in this sense, you don't want to expose each and every one to this destructive procedure. Okay, with applicable population sometimes is not available or hypothetical, means sometimes we don't know by figures the population is how much. This is what you mean by a hypothetical, or sometimes in the reference you call the infinite. Improve data quality. Okay, of course, the managing data on the small scale or smaller, you can enhance and look after the quality better than maybe a bigger data and maybe hundreds of data there. Okay, so criteria of a good sample. This is the ideal scenario. The ideal scenario, it should be representative to the population. It should be adequate sample size. It has to provide or to have the maximum precision available within the time frame or the cost that we have highlighted, and it has to minimize what we call the systematic error. Systematic error means the error related to the conduct of the study, questionnaire, for example, the response interview, whatever other points apart from the sampling. So we come to the point. The point here, how to do sampling. So the sampling procedure initially will be divided into probability or non-probability sampling. Probability and non-probability sampling are under each type or each class. We have 4 different examples that we can go one by one. So what do we mean by probability sampling? Probability sampling, actually, in brief, when each and every unit in the sampling frame, at least, have the same chance to be included. So the probability of the selection of each and every unit is non-zero. It has a chance. Okay, and that's we call sometimes the random sampling. And we sometimes it is claimed that maybe the probability sampling in general is the best way to make representativeness of the population. And because here you know the probability of each and every unit, so of course the sampling error can be computed. We can calculate the sampling error in this case. And of course, in general, making random sampling or probability sampling will be more expensive compared to the non-probability sampling that we will explain later. So let us maybe understand by example. One or the first example of probability sampling, the simple random sampling, this the classical one, or the mainstay of the probability sampling, the simple random sampling. Simple random sampling, actually, you maybe you have a number of participants, and each and every one based on the population size. You have a population size. For example, in this example, you can see our population size is 10,000, for example. The sample size is 400. This, after the calculation, we go for maybe, we estimate we at least need sample of 400 to represent a population of 10,000. Okay, so we have in this case we have maybe to calculate the probability just by dividing our sample dividing by the population size. So it gives us estimate what actually the probability of each and every unit in the 10,000 to be included as one of the 400. So how to choose this 400? By random, sometimes random number table, sometimes random number generator by the computer, and this actually the most common one to get the 400. And this, by this random, in the beginning, each and every unit will have the same probability to be included. Okay. Second example of probability sampling, also systematic sampling. So systematic sampling, actually, you just will order all the units in the sampling frame from 1 to n. N, of course, refer to the total number, and choose. You can see here, choose any random starting place from 1 to n, then sample every k units. For example, let us maybe explain by through the figure that we all see now. You can see here n is the total number of the population. We can say the population size, for example, or the study population. The sample we want 20. Okay, so we want 20 from 100. And we want to take this 20 in systematic way. Systematic here refer to the interval between each and every unit. For example, this 20 will take after how many units every time? After how many units? So one good question may come to your mind now. So where is the random here? Where the probability or the random? Because we take every fixed unit, right? So the random here, or the probability, is where to start. So the starting here, for example, because you estimate according to the population size, according to the sample size, that n divided by small n, giving you the interval. Every how many number you have to sample. Okay, then the random selection of the starting point, that can be, in this example, for example, randomly they select 4. So 4, then the interval 5 would be 9, the interval 5 would be 14, and. Another researcher, for example, will go for random. The random starting can be 1. So 1, maybe 6, and. Okay, accordingly like this. So the random here refer to the random starting of the selection of the sample within the population. Okay, what next? Stratified number sampling, and then stratified. Of course, it comes to our mind strata. Strata means cohort or group, a large group, and then actually to our understanding, stratification. So the study population from the very beginning will be divided into some particular variable of interest, like sometimes gender, sometimes ethnicity, like here, and many other characteristics that's very relevant to our research. So will be divided according to this one, and then the random sampling will be done among each and every strata. So what we call stratified random sampling. So stratified random sampling, we divided, of course, according to the characteristic of race, age, and gender. Which one to stratify or to consider for stratification? It depends on the researcher. Okay, this the researcher will decide. Has overall, because you actually eliminate some sort of variation when we bring all, for example, the male together or all the female together, we eliminate some sort of variation. So the sampling error in general will be smaller, and this would be good option if we want to ensure representativeness. While you do proportional sampling, you have to ensure that males or this ethnicity, for example, will be represented. So make sure that will be represented. And this maybe most of the time will be having some, I think, two major type. The type 1 will be stratification, or the random sampling will be done randomly, but according to the sample size. For example, if we have in Malaysia, for example, you have Malay and Chinese and Indian. Maybe Malay is majority, Chinese maybe the second one, and Indian will be the smaller one. So if you want direct proportional stratified sampling, you get more from the Malay and relatively less from the Chinese, and relatively less from the Indian. If you want to go the other way, disproportional, so you take fixed number from each and every strata. So for example, you take 100 from Malay, 100 Chinese, 100 Indian, same. You don't consider how big is this study population compared to others. Okay, so the sample here is not proportional, and this one, of course, will be of interest. Of you have some strata is already too small. Too small. If you take proportional, will be presented too small or too little of the individual, and is decision based on how important some strata or some characteristic that you want to look into with your research. The last one in the probability sampling would be a cluster or area random sampling. Cluster sampling actually this is very relevant when you do the national survey, as explained earlier. When you divide the population into maybe certain places or certain area, and you do a sampling from each and every area. So of course it will be mutually exclusive, because people in Pahang will be sampling only in Pahang, cannot be cannot be sampling everywhere. But the random sampling here within the state or within this area, within this cluster, you do random sampling. The random maybe computer generator can help to do this. So when you, in general, some insights, the stratified sampling, as we mentioned from the beginning, you were interested to compare certain groups, to compare maybe certain parameters, depends on gender, depends on ethnicity, depends on age. So you go for stratified sampling. And you're interested to minimize the sampling error as much as you can, so it would be helpful. So when to use cluster sampling, the one based on area or based on location or whatsoever, sometimes you have maybe fixed cost for each data collection location. This may be ideal example in case of the national survey, where the list of cluster but not individual population members. You have certain clusters, certain places you want to sample on, but you don't really have the individual members. So you take probability or random sampling from this one. So right now, brother and sister, we discussed the probability sampling. Probability sampling, I think we have 4 examples. If you still following. So we have the simple random sampling, we have the systematic sampling, we have a stratified random sampling, we have cluster random sampling, right? The other maybe domain or classification of the sampling is the one related, or it is all regarding the non-probability sampling. So non-probability, if you want to compare it to the probability here, actually you have probability of selecting some participant will be 0 or even unknown, you cannot compute. And usually this one, we cannot claim that it will represent the population. We cannot do this. And because the probability cannot be computed and probability is actually sometimes unknown, of course the sampling error cannot be determined. And the results cannot be projected to the population, means we cannot claim again this our findings can be generalized to the whole population. I think you have discussed with Dr. Osman. I think the generalizability of the results and what actually takes to make generalizability depends on how the sample is really representing or representative of the population. Of course, the cheaper and faster. You just go some example. One of the most widely used non-probability sampling, especially maybe in a small project like your project, would be the convenience sampling. Convenience sampling, though the convenience of access to certain participant will play a role in selecting the sample and sampling frame and. For example, for you who decided to do some research among the students and among IIM students and some maybe among third-year students, something like this. So this all example of we think about the convenient maybe sampling technique for us. This convenient sampling for the researcher, him or herself. People in the class, maybe some people maybe randomly or at the convenience at a time they available maybe in the mall, or what we have easy access to, this in general. Okay. One other example of non-probability sampling is judgment sampling. Judgment sampling. You decide whether the population to look for certain characteristics. Judgmental means the researcher, him or herself, has some input that, okay, this we will focus more maybe on the adult participant or elderly participant, although maybe all the adults are eligible. But he decided to make maybe more focus and maybe to include only maybe certain the elderly individual, for example, for some other reason. This opinion, by right, all the adult maybe population can be included, but he decided this is a judgmental sampling. Snowball sampling, this quite maybe famous in terms of when we have or we study phenomena, for example, it is really rare and no many people is aware. So we ask, when we find someone, we ask this one to refer us to maybe potential, maybe another participant, and this participant refer us to another participant, and like this. If based on referral, it will be like snowball sampling. And we have, at last, we have what we call the quota sampling. Quota sampling, actually, you can say this as stratified non-probability sampling. If you want to compare between stratified sampling and the probability and quota sampling, you can say here this the example of non-probability stratified sampling. This is a quota sampling that you identify certain quota, but the convenience sampling is there. You didn't do random sampling, you do convenience sampling. So you decided maybe to take some maybe women, some men, but you decide and you take or you include finally the ease access to. This is the 50 women, the first one you meet, maybe the one you have direct contact to. This actually the difference between the quota sampling and the stratified random sampling that we discussed earlier. So to sum up, non-probability and probability sampling. So of course, non-probability sampling, you can see, is less time consuming. Okay, those who you have access to, it is easy for you to go, you go for. The probability of selecting one element over another is not known and cannot be projected. Of course, as I mentioned, The probability cannot be computed in the non-probability. The probability of each and every individual to be included cannot be well known for all the units. And quantitative generalization actually, if you want to really make generalizability of the findings, you have to think about the probability sampling. This is the only sampling that that can do this generalizability or optimize the generalization of the results. Okay, so we come to the last part of our slot today, is sample size estimation. What actually matters for us to estimate sample size? Why not, for example, okay, everyone decide maybe 100, 200, 300, it depends on the topic. Actually, of course, because sample straightforward, it can affect the power of the study, the precision of the findings, and the power study. And if actually less or inadequate sample size will make the study overall underpowered. Underpowered study means the finding is not really credible. And from the other side, or for example, you have to include 200, and without calculation you include 400. So actually, this excessive sample size is waste for you're wasting resources. And from the beginning, we discussed this one, or how to make best of make the best use of the research efforts without wasting the resources. Research visibility, of course, this one of the main points, and of course the sample size estimation based on the sample will determine the duration, the cost, and whether or not you include participant from more than one center, like the multi-center study. Okay, this all related directly to the sample size estimation. So what actually what takes to calculate the sample size? Actually, sample size, most of the time you have to use certain estimates regarding the outcome you are going to assess or to determine. Okay, so the sample size most of the time based on the estimate will be estimate, not exact value, and some reference actually give you a number that you should not go below this number. At least you have to include this discount. Okay, we'll see some example later. Expected value. Well, the estimate actually most of the time the calculator for the sample size asks you for estimate of the parameter of the variable that you are looking for in the population. You estimate, and this estimate usually the softwares ask you to provide this estimate in terms of percentage. So how we can assume this estimate regarding the variable that will guide how large the sample or how small the sample that we want to do. So one of the points you can refer to, this estimate sometimes can be projected from similar study. For example, I give you one example. You do some research, you want to determine or to assess the prevalence of the awareness on medication disposal among the public in Pahang or Kuantan or even at a national level. Okay, so for this one we conduct research for the first time here, but from our literature review we came to know that, okay, this one study conducted in Sweden, and this study have highlighted that in average the people have the awareness in total 60%. Okay, another study in India reported 50%. Another study, okay, from Saudi Arabia have highlighted this, the awareness is around 55 or 30%. So you have certain values from previous study, and most of the time you take some estimates of based on the average, based on what is the most likely closer study design for you. For example, if the Sweden, for example, do national survey and we are aiming for the national survey, so take the Sweden one. If it is only one city and most of the time maybe you find the Indian one is conducted in one city, so you may get the Indian one on the estimate from the Indian one. So most of the time you take certain estimate, but when we talk about literature, brothers and sisters, we talk about certain estimate within the value reported in the literature. For example, you cannot maybe all the data at maximum say 60%, and the estimate you will use in the sample size is 90%. So yeah, you may be questioned from where this 90% coming, but 60% you can refer to. You have reference even to refer to. Best sample size for a specific purpose, and actually this one sometimes you have more than one objective. So the practice, or the most of the time, we plan the sample size based on the main objective. So the approach of calculating the appropriate sample size will be dependent on the study objective. It is maybe you want to determine what is your main objective. So based on the main objective, you have some sense of looking even after the estimate that you will be using in the sample size calculation. And of course, one other point regarding the study design. The study design, of course, will have a role. I will show you an example, inshallah. According to the study design, even different methods and different calculations can be there, and the input actually you are maybe required to obtain to calculate the sample size will be different. And most of the time you will see in the calculators the sample size, especially the one that relatively comprehensive, they ask you about the confidence interval, the alpha level, the beta level. Alpha maybe error and beta error, and alpha error, this is the type 1 error, and beta error, the type 2 error. Have you take with before what is alpha error, beta error, the power of study? Have you go through this one? Perhaps with Dr. Asman? Hello? Are you still here, brother and sister?
Yes. Yes, doctor.
Okay. Actually, most of the time, it seems you don't hear about this one. So no problem. Actually, it is just easy. Alpha error and beta error. Beta error actually refer to the false negative. The alpha error refer to the false positive. False positive means there is no difference, but mistakenly by error, it is there is a difference over there. Okay, in each and every study, there will be an alpha error acceptable range. Most of the time is 5%, and that's why actually sometimes you have the confidence interval 95%, because the 5%, the range for the alpha error, the false positive, that usually will be attributed to the chance, or the one maybe we talk about the non-systematic error, will be acceptable at large for 5%. On the other hand, the beta error, the type 2 error, is false negative. False negative means what? Means actually the study showed difference between certain intervention and the others, but due to mistakes happen on the way, this difference cannot be detected. So they give us false negative. I think this one will be explained in details with in the statistical part. I think with statistical tutorial you will be guided maybe thoroughly on this one. But here I highlight because it is just relevant to see the relation between the errors and the sample size. Usually, if you have maybe acceptable range of the error, and you want to accept more range, so you have to have more larger sample size. So for example, the alpha error is acceptable at 5. So perhaps this 5%, your calculation of sample size will be around, roughly, will be around, for example, 200. Perhaps this alpha error, you want to make it, no, it is not 5%, I want to make it 10%. So in this case, actually, the sample size will be higher. So the effect on the sample size, when you accept more range of error, will be higher. How big sample do I require? There are so many examples you can refer to, starting with the formula that you can be calculated maybe manually, the expected prevalence of the proportion within the population. You can see here, brothers and sisters, precision refer to the point, what we called maybe the 5%. The 5% we have highlighted, but sometimes the terminology is different. The P, the expected prevalence or proportion, the one we talk about the estimate. What actually the P, the proportion, the estimate for this variable that we expect from based on literature, based on previous study, based on similar settings would be there. Okay. Confidence interval 95% means the type 1 error is just 5%. Just example of equations that can be used. The finite population correction, you can see here maybe this calculation and the sample size, population size, and these statistics for level of confidence, and this expected proportion again for this one, and the precision as highlighted earlier. Expected proportion, the one we talk about, the estimate most of the time is a percentage. Most of the time is a percentage, and most of the time it can be determined in a scale from 1 to 100, or if you want as a number from 0 to 1 as a fraction. Usually, as I mentioned, for this one, you have to look back to the previous or similar or the experience that you have for this variable expected to be on the population. Come to the last maybe part. Of course, nowadays it's more toward the softwares. It is not actually maybe calculation based, and you have to do maybe calculation for the statistics and calculation for everyone. It is not like this. So we go for free online calculators most of the time. You have certain maybe free one and with license one. I can show you one of the two most commonly used calculator for the sample size. Of course, this one, RASOFT, is very popular in survey research, and you can see here it is very simple. Actually, it's even not requiring too much of the data that you have entered, and it will calculate for you the recommended sample size. You can see here, actually, brother and sister, what margin of error you can accept. This here refer to alpha or type 1 error. Type 1 error that we talk about this one. Most of the time it is within 5%. And what confidence level? Most likely would be 95%. If you are very confident and you want to accept less error, you can go for even 99% and make the margin of error is 1%, up to you. What is the population size? The population size means the general frame, and this one actually most of the time in convenience sampling, and maybe if you don't have the precise number or the accurate number, you can just also maybe estimate. But usually, it is not different that much after 20,000. For example, 20,000 from 30,000 from 40,000 as a population size will not affect much actually the number of the sample size. And come to the points that we have discussed so many times regarding the estimate. You can see here the estimate, what is the response distribution? What is the estimate of the main variable of your research that you expect, the expected estimate, the expected distribution, the expected outcome. Okay, this again estimate you can bring or you can refer to from literature or similar study. Okay, so Rasoft calculator is very simple and can be suited for the survey research. Come to other one to show you how the study design can be of impact on the sample size calculation. You can see here this is the OpenEP one, the second online calculator, the free one. You can access through the link I have provided. You can see here, for example, if you have a descriptive study that you are aiming to, for example, to estimate a proportion of patients who are aware, proportion of students who are knowledgeable, proportion of patients who have maybe certain attitudes or perception on. So all these are proportion, right? And descriptive study. So for descriptive study, you go for this calculation, and again, you can see here the population size, anticipated frequency. Again, this is the proportion of the estimate that we have highlighted so many times. The confidence interval, the error, and the design effect, which you usually will refer as 1. You can see here another example, the unmatched case control study. You can see here one example of the cohort. All these are ready-made online calculator that already over there. Okay, you can have a look on this online calculator, and by this I think I have finished. Just go through the online calculator and the two examples I have provided, and let me know, inshallah, if you have any questions or any points that you want to discuss. Okay. Any other points or questions, sister and brothers, before we end our session?
I think so far no, doctor.
Okay. So it is good for you, so we can get some break before the next slot. Okay, we can. If no more questions, we can end our session by tasbih kafara and surah al-asr. سبحانك اللهم وبحمدك أشهد أن لا إله إلا أنت أستغفرك وأتوب إليك. بسم الله الرحمن الرحيم. العصر إن الإنسان في خسر إلا الذين آمنوا وعملوا الصالحات وتواصوا بالحق وتواصوا بالصبر. سبحان ربك رب العزة عما يصفون وسلام على المرسلين والحمد لله رب العالمين. Okay, thank you so much. Assalamu alaikum.
Thank you, doctor.
Thank you.
Thank you, doctor.
Thank you.